Lesson 8.7 is factoring special products. In a previous lesson, you learned how to multiply the special products, and now we're going to undo that. So the first one we have is the difference of two squares, and the difference of two squares will always, always, always be in the form a squared minus b squared. So this is what we're interested in. And to break it down, you take the square root of the first term, the square root of the second term, and you separate it by addition and subtraction. So for example, 4x squared, I know the square root of 4x squared is 2x. I know the square root of 9 is 3, so I simply go 2x plus 3 and 2x minus 3. These are pretty easy. They're always in the same format, where you're going to have only two terms and they're both going to be perfect squared separated by a subtraction sign. Now, as with anything, the first thing you want to do is you want to go ahead and see if there's a greatest common factor. So in 4y squared minus 64, the greatest common factor is 4. When I factor it out, I get a y squared minus 16. And now I keep going. So this is 4. The square root of y squared is y. I'm going to go plus and minus. The square root of 16 is 4. So if I were to multiply this all together, I would end up with 4y squared minus 64 if I were to FOIL and then multiply by 4. Now, the reason that we don't just go the square root here is because it's not completely factored. Yes, the square root of 4y squared is 2y, and the square root of 64 is 8, so I could go 2y plus 8, 2y minus 8. But you see that these still have a greatest common factor of 2, so each of them would have to have a 2 factored out, ultimately making me factor out the 4. So let's do a few of these. I've got x squared minus 36, that's just x plus 6, and x minus 6. 25p squared minus 144, the square root of 25p squared is 5p. The square root of 144 is 12. So 5p plus 12, 5p minus 12. We've got 36 and 81. The greatest common factor of 36 and 81, I believe, is 6. Let me double check. Nope, it's not 6. I was wrong. I know that, actually it's a 9. My bad, it's a 9. So if I factor out a 9, I'm going to get a 4m squared minus 9, and now I want to keep going. The square root of 4m squared is 2m, the square root of 9 is 3. So 2m plus 3, 2m minus 3, but you have to have that factor of 9 pulled out. And now here, negative 2 is not a perfect square, and this certainly isn't a subtraction sign. So what I need to do is factor out the negative 2. That does now leave me with a positive x squared and a minus 16. So the resulting binomial here is the square of a sum and a difference. So I have negative 2, the square root of x squared is x, the square root of 16 is 4. So sometimes we have to manipulate them so that they're in the form that we want. And then the next type of special product is the perfect square trinomial. These are the ones where they're in the form a squared plus 2ab plus b squared, and then a squared minus 2ab plus b squared. To recognize them, you're going to see that your first and last terms are perfect squares. The last term will always, 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 always be positive. And then when you square them, you're going to see that 2 times the first term times the second term in your binomial will end up equaling the middle term. So let's go ahead and look at these right here. So I have 9c squared plus 24c plus 16. I do not have a common factor, so I'm going to go ahead and say, well, the square root of 9c squared is 3c. Since my middle term is positive, I'm going to go plus. The square root of 16 is 4. And now I just have to double check. 3c times 4 is 12c, times 2 is 24c, so it worked. Let's try this one. Again, I don't have a greatest common factor, so the square root of 25w squared is 5w. Right here, there's a subtraction sign for the middle term, so I'm going to put subtraction, and the square root of 4 is 2. So 5w times 2 is 10w, times 2 is 20w, and there's a subtraction, so it does work. Right here, my greatest common factor is a negative 2. And I know that I have to pull out something because 18 is not a perfect square. So if I pull out a negative 2, I'm going to get a 9a squared plus 6a plus 1. And now I do have my perfect square trinomial. The square root of 9a squared is 3a plus the square root of 1 is 1. Don't forget the binomial is squared. 3 times 1 is 3. Double that, you get 6, and we have the a in there, so it's good. And then finally on this last one, I do have to pull out, I can pull out at least a 5. When I divide through, I get a 4z squared minus, let's see, that's going to be a 28z plus 49. And 4 and 49 are both perfect squares, so I know I'm on the right track. So I've got the square root of 4z squared is 2z minus the square root of 49 is 7. And now to check it, 2z times 7 is 14z, double it and you get a 28z, and it is subtraction. So we're all good here. Alright, next I believe we're going to solve some of these trinomials, these polynomials. So we're going to do it the same way. You always have to make sure that it's set equal to 0. So this is a perfect square trinomial. I get x plus 7 squared equals 0. Since they are the same, I really only need to take one factor, set it to 0, and I get a negative 7, since they're both the same. First thing I have to do here is subtract the 50 to set it to 0. Now I'm going to go ahead and factor out a 2, and I get 4w squared minus 25. So this is now in the form of the sum of a square, sum and difference pattern. So the square root of 4w squared is 2w. The square root of 25 is 5, so 2w plus 5, 2w minus 5. This 2 is not necessary, so I just write down 2w plus 5 equals 0, 2w minus 5 equals 0. For this one, I'll subtract 5, divide by 2. Here, it's the opposite. I'll add 5 and divide by 2. Let's try this one. Oops. Perfect square trinomial. The square root of 64p squared is 8p. The square root of 1 is 1. I'm separating it with a subtraction sign because I have subtraction here in the middle. And so again, I still only have one factor that I need because they're the same. So I will add 1, divide by 8. So p is just 1/8. Here I can pull out an 8. I have a squared minus 9. So I have 8 times a plus 3 times a minus 3. The 8 again is not needed, so I have a plus 3 equals 0 and a minus 3 equals 0. So a equals negative 3 and a equals positive 3. Here, again, since this section is perfect square trinomials and sum and difference patterns, I know that I can factor something out, and here the greatest common factor is a 3. So I get m squared plus 10m plus 25, and now I can factor that into m plus 5 squared. And again, I know it's addition because this middle term is addition. So I have actually the 3 I don't need anymore. I can just take the m plus 5, only one copy because again there's 2, so I don't need both of them, they're the same answer. M equals negative 5. And always we want to factor out the negative, and 4 is a factor of each of these. So I end up with y squared minus 8y plus 16 equals 0. So negative 4. And then the square root of y squared is y, the square root of 16 is 4, but it's a negative because of the middle term. And again, one more time, I only need one of those factors to 0, and y equals 4. And again, I only need one of them because they are identical. Here I did need both of them because they were opposites. Alright, last problem. We're going to use the vertical motion model, and recall that the vertical motion model is h equals negative 16t squared plus vt plus s. Make sure you commit that to memory. A window washer drops a wet sponge from a height of 64 feet. After how many seconds does the sponge land on the ground? So in this particular case, We want to know when it lands on the ground, so we're going to set it equal to 0. But he's not forcing the sponge, so we don't have an initial vertical velocity. So we have our acceleration or deceleration, it's going down, plus, because he starts at 64 feet. So I have no middle term in this case. What I need to do now is I can factor out a negative 16, and when I do that, I end up with a t squared minus 4. So 0 equals negative 16, and then t plus 2 and t minus 2. So again, I don't need the negative 16. I'll go t plus 2 equals 0 and t minus 2 equals 0. So t algebraically equals negative 2 and algebraically it equals positive 2. Well, I cannot have negative time, so it's going to take 2 seconds for that sponge to fall on the ground. Alright, so if you want to get started on this, this is lesson 8.7, and the problems begin on page 545 to 546. That's a 5. And it's numbers 4 to 38 even. And 46 to 48.